In this video, we will look at creating a dynamic two-dimensional array. First of all, let's look at a little bit of a review. In this program, there are a couple of regular arrays declared. We just have an unsigned integer array, values 20 all set to 0. And here's a 2D array, numbers that's 4 by 10 all set to 0. And I'm using a couple of functions that we will use to initialize them and to print them out. So we've got an initialize 1D and a print array 1D function. And here I'm calling an initialize 2D array and a print 2D array. So let's scroll down and look at those functions briefly. So they're way down here. In the case of initialize 1D, it's very easy to pass an array in, and it doesn't matter how big the array is. The parameter, the formal parameter, is just the name of the dummy argument here, the formal argument, and you can use an empty set of brackets. So that means that this function will accept any size array, and will also pass in how big that array is. In the case of the two-dimensional array, though, we have a problem. We have to specify the number of columns. We cannot leave that empty. We have to put a value there. And in addition to that, any array that we pass into the function, it has to have exactly 10 columns. So that might be an issue, because what if you wanted to have an array that had 20 columns? Then you couldn't call this function to print it. You'd have to write another function that had 20 here for the number of columns. The dynamic array that we will look at in this lesson will show you a way that you can get around that. You can have one function that will print out an array with any number of rows and any number of columns. Now let's scroll back up to the top, and when we are calling the functions, you see that we are calling initialize 2D and print 2D. Then we pass in the array numbers, and that array numbers has to have exactly 10 columns. Let me show you that there's an error if we try to call the function either initialize 2D or print array 2D with a different number of columns. So temporarily, I'm going to change that 10 to an 8, and then you'll immediately see that we have red underscores. And the error that we're getting, if I can keep that up, it's saying that the argument with 8 columns is incompatible with the 10 column dimension of the function. All right, so that's the problem that we've run into, and this program will show you an alternative way that you can use to solve that problem. So let's put this back at 10. And let's actually go ahead and compile and run the program. You can also see we have the prototypes for all those functions up there. So let's compile and run the program, and we'll see what the output looks like. Then the program will stop right there. Then we'll move into the dynamic arrays after we illustrate what these initialize and print functions do. So I'm just going to build this program, and then I'm going to run it. So the window has appeared, and shortly we'll see the output. Here we go. In this output, you can see that I printed out the elements of the array for values. So it's just a one-dimensional array with 20 values, and you can see those printed out here. The far right-hand column shows the actual address where these elements of the array are stored in memory. If we scroll down, then I've also called the initialize and print function for the 2D array, which is 4 by 10. So here you can see the output from that array. Okay, so there's the first row, index 0, the second one, index 1, the third one, index 2, the fourth one, 3. So here are the output values of our 4 by 10 array. And then we have stopped temporarily at this point. So I'll stop the program, And let me scroll back down to the functions one more time because I do want to point out the output of the address. And the print array 1D function, the output is just we pass in the one-dimensional array, and we have the for loop that will print out this cout statement, or will execute the cout statement. So the output is just a nice string constant with array with a left bracket, and we'll print out the k index, close the right bracket, then actually print the actual number here. And then I wanted to point this out. If I want to print out the address of anything, a regular variable or an element of an array, then I use the ampersand, which is the address operator, and I'm going to convert that to a type int. If I do not do this, then the address comes out as a hexadecimal value, which is a little harder to read than just a decimal value. Okay, so that's where that table is generated. We have the variable and the contents and the address. Now, let's scroll back up and write some code that will generate a dynamic array. Okay, so we'll move down to here. If we want to make a dynamic array, then of course we need some pointers to do that. So I want to make a pointer to an unsigned integer, and I want to make 4 one-dimensional arrays. So I'm going to call these star row 1, star row 2, star row 3, and then finally star row 4. And let's change that, change my typing to a comma. And again, Visual Studio prefers that syntax, but I do not. So I like to have my asterisk immediately to the left of my variable. All right, so now we have the pointers for 4 one-dimensional arrays of unsigned integers. Okay, they don't have a value yet, so we do need to initialize them. And to initialize them, we need to use the new designator. And I want to also type in how big I want these arrays to be. So let's put that down here. All right, so we'll create the 4 one-dimensional dynamic arrays, but the user gets to choose how many columns. All right. So after we input the number of columns, then we can do the new. All right, so we can initialize them now. So row 1 is equal to a new unsigned integer. And the number of columns that we input will be how large the array is. All right. Now this new operation is just requesting some space from the operating system. So the operating system finds the space, it returns the address in row 1. This created a one-dimensional array called row 1. Now let's do the other 3. So I'll just copy and paste, do a little bit of editing. So now I just need to make that row 2, row 3, and row 4. So this generated 4 one-dimensional arrays. These are 4 one-dimensional dynamic arrays because we're using new, and we've input the size that we want. So all of this takes place when the program is running, not during the time it's compiled. We want to initialize the 4 one-dimensional arrays, so we have a function that will do that. We already have this initialize the 1D function. So we'll do initialize 1D, and the argument will just be row 1, and how big is it? Whatever the user wanted to type in. So we can pass row 1 to the function, and we can use it as we would an ordinary one-dimensional array with the square brackets. I want to initialize the remaining 3 arrays, so I'll just cut and paste or copy and paste and change this to row 2, this to row 3, and this to row 4, so we can print out the values. We can initialize them, and then we can print out the contents of the arrays. what I have done here is I've already got some code to do that, and I had just commented that out because I didn't have these row 1 through row 4 generated yet, and it would not compile otherwise. So now that we have allocated the space and that we have initialized them, then we can print them out, and I'll just uncomment these lines of code. So this will print out the contents of row 1. The next one will print out the contents of row 2. Then we'll do row 3. And finally, we'll do row 4. So we're calling the print1d function, and it will print out the values that were loaded into these one-dimensional arrays. Now, remember, we created these arrays dynamically with new, but we can treat them just like an ordinary static array and pass them to the function. So we can initialize 1D, we can use the square brackets here, so that is perfectly fine. Now let's compile and run the program, and let's see what the values were for these 4 arrays. So the program has compiled and it is running. So here we see the previous output from just the one-dimensional array of values. Here's the two-dimensional array, the 4x10 array. Then we are down to the system pause. Let's hit enter or space key. And how many columns do we want? Dynamically for each one of these, we want 5. And here is the output. So this says row 1 is stored in memory at this address. That's the actual location where this pointer is stored. And it contains the value 7176992. So row 1 is a pointer, and it points to the address of the first element of this array 0 in the function, and we're passing in row 1, so that's a row 1 sub 0. Row 2 is also a dynamic array. It has a place where the pointer is stored. That's its address. The pointer contains this address, and that points to the first location of the row 2 array. One thing you should notice is that these are not stored in consecutive locations. So this address points to the beginning of this array with 5 elements. These numbers are consecutive, but when I generate the second dynamic one-dimensional array, it is not at the consecutive to the last element here. So these 4 dynamic arrays are stored in 4 different blocks of memory. Each element of each array is consecutive, as you can see here, but these 4 different arrays are stored in different blocks of memory. So that will be important in what we'll be looking at shortly. So let's stop the program at this point. Now, what I'd like to do at this point is to look at a graphical representation of what this program has done up to this point. So I'm going to switch to a PowerPoint presentation or a couple of charts to show graphically what we have just done with the program. Now let's look at a PowerPoint chart that will illustrate what we just did. This PowerPoint chart, on the left-hand side, I've copied and pasted the code from the program. On the right side, you will see 4 tables, and they represent each of the 4 one-dimensional arrays that were produced. Up at the top, I'm assuming row 1 is going to point to address 2000, which is the first element of the row 1 5-element array. The table shows the pointer notation at the top row. The square bracket notation is the second row. That's what the variable is pointing to. The contents will be the numbers produced by the random number generator, and the bottom one shows the addresses where each of these items is stored. So the first element of the array is 2000, the second one 2004, the third one 2008. So unsigned integers take 4 bytes, so that's why these go by 4. The remaining tables, row 2, row 3, row 4, also show graphically what is produced when we do the new unsigned integer for row 2, row 3, and row 4. I'm just picking some numbers for the addresses, 1104 for row 2, 1184 for row 3, and 1264 for row 4. So when we execute the new unsigned integer and we have the 5 columns that I entered, then we call the initialize function. Then this is what we get in memory. So these 4 groups of 5 element arrays, we have 4 one-dimensional arrays with 5 elements, those are stored in memory at some location. So we will use these 4 one-dimensional arrays coming up when we get back to the program. Now let's add to the program. In this area, it says make an array of pointers to an unsigned integer. Notice what this says. It says make an array of pointers. So we're going to have a variable that's going to be an array, but it's going to have pointers as the contents. Alrighty, so I want to set the rows equal to 4 because we made 4 rows previously up above. And I want to declare a new variable, which is an unsigned integer, but it's a pointer to an unsigned integer, and I'll call it table. And I am going to make it this many rows. So I could put 4 here, or I could just put rows there. Alrighty, now this line of code is, well, why does it not like that? Okay, well, let's just put 4 in here. Now, what this is saying is that this variable table, which has 4 elements, will contain pointers to unsigned integers. So it will not contain just regular unsigned integers, it will contain pointers. Now, let's initialize this table with the pointers to the 4 one-dimensional arrays that we did up above. And we'll just do this. Type each one in. So table element number 0 is equal to row 1. So row 1 is what was produced when we did a new operation up above, right here. So we had an address returned, and that was saved in row 1. So row 1, sure enough, that's a pointer to an unsigned integer. So we're going to save that as an element of this table, which is a table containing pointers to unsigned integers. Okay, so let's copy and paste. We'll do the other 3. So we'll set these indices, table 1, table 2, and table 3. And we will make table 1, it'll contain the address of row 2. Table sub 2 contains the address of row 3. Table sub 3 contains the address of row 4. So we have now just loaded in these 4 pointers into the table. Down below we have case number 1, we have a cout statement which says we want to print out the dynamic array for table case 1. Well, the dynamic array part of this is not the table itself, but it is what the elements of the table point to. So row 1, 2, 3, and 4, those are all dynamic arrays. Now we have a function already that will print out a one-dimensional array. So it's down here. So we have print array 1D, so we can use that. And we have to be careful about what we send into it. Right, so now let's back up and let's call this function. And we need to print out all of the elements of the table. So let's just do for int k is equal to 0, k less than 4, k plus plus. I've got a lowercase k. Then we just need to call print array. So print array 1D, and the thing that we need to send to it is going to be each row of the table. So this index, or this argument is going to be table sub k. So the print function is just expecting one table of unsigned integers. So this will be the pointer to that. And how many elements does it have? Well, we already know that it contains a number of columns that we entered up above when we did the new operations for row 1 through row 4, and it was 5. Now, let's put a system pause here so we don't go any further, and then we'll compile and run the program. We'll put the correct print over here. Okay, now let's compile it and run, and let's see what we get. Here's the output. We had the previous output from the program we did last time showing up here, and now we've reached the part of the program where we type in how many elements we want in each of these one-dimensional arrays. We chose 5, and then we did print out the contents of those 5 rows. Let me ask you to remember these numbers here. This is row 1. Okay, so array 0, 1, 2, 3, 4. So those are 5 elements for the table row 1. 16, 35, 90, 42, and 38. So keep those in mind as we go down. As we get to the bottom here, I am ready to hit the enter key, and we will do this part of the code that we just typed in where we put some values into a table. So I'll hit the enter key, and we now have executed this part of the code, and we have gone through our little for loop to print out the values. If you look back at what we have, then this says print dynamic array table case 1. So that came from right here. And the output of that is the same as we got up above. So table sub 0 is passed in, and it's a one-dimensional array, or it's a pointer to a one-dimensional array. And here are those same numbers, 16, 35, 90, 42, and 88. So what we have done here when we passed in table sub k is exactly equivalent to what we did up above when we passed in row 1, row 2, row 3, and row 4. That shouldn't come as any surprise because we set the elements of the table to these pointers, row 1, 2, 3, and 4. Now what I want to do before we go on is I want to stop for a moment and bring back in another chart that illustrates what we just did. So I'm going to switch to a PowerPoint chart. This chart shows a picture of what we just did. On the far left, I have just copied and pasted the code. So we had the rows as 4, and we did the unsigned integer pointer to table. So now the table is there, and it contains these addresses. We loaded up the table with the addresses, the pointers, row 1 through row 4. Directly below that, you'll see a table that represents the table variable, and I'm showing you the variable, what the notation is, pointer notation, the variable with bracket notation, and then look at the contents column. So table sub 0 contains 2000, and that is the 2000 that we are just assuming is going to be assigned as the address of row 1. The contents of the second one, the second element, index 1, is 1104, and that's just the address of a row 2. And then so on down the list. So just using those numbers I made up, then you can see that the table indices 0, 1, 2, 3, and 4, those contain the addresses of row 1, row 2, row 3, row 4. The column on the far right, I'm just picking some addresses where the table could be stored in memory. So the actual table, I'm assuming, could be at addresses 2800 through 2812. But the actual contents of each of the locations is shown as 2000, 1104, 1184, and 1264. I've also added some arrows so you can see that the table contains pointers to the 4 one-dimensional arrays that we previously created. In the second part of this video, let's come back and let's print out the dynamic array table case number 2. So we'll do it a little bit differently. But before we get there, what I want to do is to come down here and do some cout statements to show you some of the equivalent things that we now have. To do that, let's just print out some things with some simple cout statements. So here's the first one, cout, and I want to print out row sub 0. So I'll just write row 1, bracket 0. That's what I want to print out. And I'll just do it like this, equals, and then I'll print out row 1, bracket 0, with an end line. So this is the most common thing that you've seen. So with the one-dimensional array, you've seen this over and over again. We also, in previous lessons, have looked at pointers and used the pointer notation. So let's print that out too. So that would be an asterisk row 1 equals. Then this would also print out the first element. So this is a pointer notation. So star row 1 with an end line. And we know that those are exactly the same thing. This notation with a square bracket, we can use pointer notation and we can print out the elements of the array equally well. Now, let's do one more. Let's print out our table. Let's do cout and let's print out star. Double quote, I want to do star table bracket 0 equals, and that's just the comment part. So I'll just copy and paste. So copy, paste, end line. And this is also the same thing. We have asterisk row 1. If we dereference the address row 1, then we will get whatever the first element of that row is. Well, up here, we set row 1 as the item that's stored into index 0 of the table, where table contains pointers to unsigned integers. So down here, if we dereference table 0, that's exactly the same thing as dereferencing address row 1. So those should be the same thing. Now, let's go ahead and let's compile and run and look at what the output would be from these three cout statements. Now we have the output, and I've already entered the information we needed for the program to progress down to this point. But now let's look at the output from those cout statements. Okay, row 1 bracket 0 is 16, and we see here that if we dereference row 1, we still get the same thing. And if we dereference the element of table 0, which is just a pointer, row 1, we also get 16. So these three cout statements give us the same result. If we scroll back up, then we can see what we're looking at here. This is where we printed out array 1 from the function, and that was row 1, index 0, and it contains 16. So that's what we're printing out. Now let's stop the program and let's add a couple of additional cout statements. So now we're back in looking at the code, and these next two are the ones that are the most important. Let's do cout and let's output a double quote table and use 2 brackets equals. And again, I'll copy and paste. And an end line. So I have taken something that was a one-dimensional array table, but now I'm using a double index to print it out. Now, if you look carefully, then table bracket 0 has an asterisk just to the left. And as you know, if we take this entire thing, table index 0, as a single item, we have the dereferencing operator here, then we can also rewrite that just using the standard bracket notation where we do not have the asterisk. Okay, so note what I'm doing there. This thing, table bracket 0, that is one item, and I'm dereferencing it, then I can equally well use a square bracket. So that's what's happening down here. I have table 0, and in this instance, I don't have the asterisk anymore. I can equally represent that with a bracket notation. So I'm adding on a second set of square brackets, which in effect gives me a two-dimensional array. Wow. Now, if I can do that, then I can also go in the other direction. If I have something that I can represent with a bracket notation, then I can also use pointer notation for that. So here I'm using a double square bracket notation. Let's switch that to a double pointer. So let's do cout, asterisk. Let's do a double quote first, asterisk, asterisk, table. equals. And then over here, we'll print out the double pointer notation for the table with a nice end line. So these are equivalent. I'm showing you the comments here. The actual printout would be from here. But this notation with the double bracket is equivalent to that double pointer notation. So let's make sure that's correct by compiling and running the program. Okay, so now we have the results. And again, I have proceeded all the way down to the end of the program to show you these cout statements. And you can see now that if I'm using the double bracket notation, then I'm getting the value 16. If I use the double pointer notation, I also get the value 16. So all 5 of those cout statements allow me to print out the first element of row 1. Now, let's return to the program where we want to print out the dynamic array table case 2. To do that, I'm going to call a function. And let's go down and look at our functions. So here we have the print array 1D. I don't want that one. And here's print array 2D. Quickly, if you look at print array 2D, this is the way we've been printing out or calling a function with a two-dimensional array. We have to specify the number of columns. In this instance, we do not have to do that. So the last function is called print array 2D star. This part of the code is exactly the same as the code we have here, where we have the double bracket notation. The only thing we have to change is that formal argument. So instead of using the double square bracket notation, where the second one has to contain a number of columns, we're just switching to the double pointer notation. Everything else stays the same. Inside the function, it's perfectly fine to use the double square bracket notation. So we just need to call this function, and we can print out the table. So let's scroll back up. Here we go. Print dynamic array table case 2. Easy enough. So we call print array 2D star. That's the function where I'm using the double star notation, a double pointer notation. Then we just send it table, which is our two-dimensional array. We're thinking of it now as a two-dimensional array. And it has a certain number of rows, 4 in this case. And the number of columns depends on the user. So whatever that number is, that's what we will pass into the function. So now we can call the print 2D star and we'll send it table. So compile and run. I did get an error because I did not create the prototype, so I forgot. So let me go make the prototype. So I'll copy the first line, okay, Control C, and paste it to create the prototype. Have to have that. So paste that, add semicolon, and now let's try that again. Now the program's running, and I stopped it at the point where I'll type in a number of elements in the row. I'll type in 5 to be consistent. Okay, so that's good. We did print this out, and we'll hit continue one more time. And here is where we print out the dynamic array table case number 2. So that's where we call the function. Look at it one more time. Okay, so that's the call right there. And here's the output. So in this instance, I'm calling print 2D star. The output works just fine. And then at the very end, we get those cout statements. But if we look back at that function, then you can see that when I change that formal argument to this notation, it works just fine. Now the last thing I want to do is let's change up the size of that array. And instead of having 5 columns, let's make it a different number of columns. So I'll run the program again. I don't have to change anything else. I'll just run it. Okay, so we got the output. Any key to continue. So this time, enter the number of elements. Okay, well, This is be the number of columns. So let me put in 8 this time. So we'll have a 4 by 8 array. So here we go. So we have an array 0. Okay, let's go to the next one. And here is our two-dimensional array. So here the first index is 0, 1, 2, 3, just like before. But now the number of columns has changed. So the number of elements per row, which is the number of columns, is 8 this time. Previously we had 5. But when I call the function print to the star, it prints out the array, which is now 4 by 8. So I didn't change the function at all. It can accept any number of columns, and that was what we were trying to get to. We were trying to write a function such that it would handle an array with any number of rows and any number of columns, and that will do it. So that will end this video, and the next one coming up, I'm going to show you just an example that has only the code necessary in order to create a dynamic 2D array. So I know you'll be excited to see that one. But anyway, that's all for this one, and I'll terminate the video here.